really good to be here. Like, I've known about the Gun Institute since I was a graduate student. This is my first time here. So thank you very much, Dr. Google, for inviting me. And you guys, we had a workshop yesterday. Like, the culture you guys have here is pretty remarkable. So it's a really fun place to be. So it's nice to be here. I'm in Michigan State currently. I also have an appointment at NIST. They're the people that measure stuff for the federal government. So they bring you things like the gallon and the inch. They're really famous for that. And also the Collective Institute at Copenhagen for collective intelligence. I have 139 slides, but I don't use a lot of animation, so don't worry too much. I might go over some stuff really quickly. Some of you already saw this yesterday. So how did I end up here at the Gun Institute on this nice fall day? When I entered graduate school, I was very much interested in bycatch and commercial fisheries. And bycatch is just anything commercial fishermen catch that they can't sell on the market. They don't want to catch it. The environmental groups don't want them to catch it, and no one doesn't want them to catch it. So no one is for bycatch of any sort. And in a lot of fisheries, you catch certain types of fish, like turtles, this fish will be shut down completely. So I was very interested in going to Rutgers to work with their oceanography team to understand how to deal with bycatch. And at the time, this was very new technology at the time. We had data sets for the physical ocean, so sea surface temperature, depth, and temperature, and so on, chlorophyll. And we had NOAA's trawl survey data for how many fish and what type of where. And so we wanted to put those together to make habitat models. And at the time, fisheries management in the area was concerned about butterfish bycatch. Butterfish assessment was this little tiny guy up in the corner, really cute. There's no market for it. There was in Japan for a little bit, but there's the assessment for butterfish was very low, and they were catching too many in the loligo squid fishery. So there was this threat that they were going to shut down the fishery if too many of those butterfish were caught. So we said, okay, well, we can put together a habitat model that's dynamic and show where high probability areas of butterfish might be. And so we can tell the fishermen, just don't fish in these areas. And I don't know if you know how fishery management works. It's very participatory. There's different councils around the United States, and they come together in a participatory way to manage fishery and negotiate what does sustainability mean. And they are 3-day meetings that look just like this. There's decision makers and commercial fishermen. It's a very diverse group, seafood industry, all of these different stakeholder groups, which make it really ideal model for understanding conservation conflict, public participation, and all sorts of things. And what we did, given the nature of this bycatch issue, was we came in and said, you guys, we solved your problem. And we were laughed out of there. The way they understood it is as a resource assessment issue. And they were like, there's no way that we can solve this problem with those dumb maps. For one reason, that red that you see here, the red that you see here, is also loligo habitat. So they're the same. The butterfish habitat and loligo habitat are the same. That's why you catch so many butterfish with the loligo squid fishery. So it's not surprising. But this was a very humbling experience. It was my introduction to a couple of things. One is this idea of a type 3 error. I don't know if engineers in here might know what it means, but a type 1 error is rejecting the null hypothesis when it's true. A type 2 is accepting the null when the hypothesis is false. And the type 3 error is providing the right answer to the wrong question. So we have this technology and we're trying to shove it and shoehorn it into a problem to make ourselves feel better. And if you look at this model, so this is the continental shelf, obviously, and commercial fishermen are making decisions on 2-kilometer and 2-hour scales. So this was our analysis area, and this was the fisherman scale at which they're working. And you'll notice it's going to stay red the entire time. So it's going to always be butterfish habitat. So this was ridiculous. It was also very much a real exposure to what a wicked problem looks like when you're dealing with other people who are trying to address it or manage it. And where traditional problems, we have engineering solutions. So if we have a river between 2 land masses, we can build a bridge. But what I've been interested in is in technological and social innovation to better manage wicked problems, of which we have a lot of different case studies. And so going to these fishery management meetings, I thought was really interesting. So I would just listen to the stakeholders argue different points. And they all just have different mental models, different ideas about the nature of the problem. And it occurred to me, can we come up with some kind of intervention where rather than these different ideas or a liability, we can kind of see where different values, different beliefs, different understandings of the way the system works come together for negotiation to increase decision-making and kind of equity. So I got into this area of what I call knowledge integration. There's a lot of the literature comes from like management and business, trying to look at groups and how they make decisions, which is really interesting. And it has a lot of implications for how to organize knowledge in a way that increases the decision-making capacity within groups. And so I started doing it in the environmental field, but it's also been the methods we've been applying to things like public health, vaccines, and food security. So what we did years and years ago was there was an INSEAS working group that I was a part of that was really rewarding, where we began to think about how do knowledge systems exist in sustainability? So how can we apply some theories about knowledge systems within sustainability in particular? And it took 34 of us to come up with this very simple answer, which was, if you think about scientific knowledge and locally situated knowledge, one scenario is they just exist and they never touch, right? There's just never the two shall meet. Now, it can also be rejected. And so scientific information can be rejected on the local scale, but also the other way around, right? And what we want is for these things to be integrated. So again, there's about 35 people working 2 workshops, came up with these 3 graphics, earth-shattering. And this is kind of obvious. We want information to be integrated, but the question is, how do we do that in the real world? So then I started to develop a software called Mental Modeler. And again, this was really influenced by going to fishery management meetings and seeing people argue, can we come up with a participatory modeling tool where people can share ideas in different ways? We won't have to go through all of that. It's so domain flexible, and those of you in the workshop yesterday saw it's almost too flexible and too generalizable. We've been applying it in lots of different areas too. It is a methodology, but we're applying it to answer a range of different questions. We've been looking at traditional ecological knowledge and scientific knowledge in fisheries in the Pacific Northwest, in tsunami planning. I mentioned this yesterday to the group at the workshop. Interestingly, like a lot of accidents that happen on oil rigs and oil spills are human error because people are not talking to each other. And so there's a huge communication issue, and that ends with people losing their arms and such. So how can we understand the mental models of these guys that are on these rigs, and how can we coordinate their action together? Flooding in Boston, Tanzania, bushmeat, and we use it with a series of farmers in computational agriculture in places like Nepal and India. So this got me thinking, using fuzzy cognitive maps and mental modeling was really useful, but then I was like, this is just one tool. Why don't we get together and talk about what a toolbox looked for, so we're not trying to apply FCM to like every problem that there is. So we put together a working group with Succinct. We had about 25 different people in that group. They were all kind of different experts about different methods that were participatory around sustainability. And we began to organize the different methods that are available into different use cases to figure out when is it better to use a qualitative concept map versus a system dynamics model versus Bayesian beliefs, and what are the trade-offs between these. So we kind of moved from like fact-finding to orchestrating a process to definitely qualitative modeling, things like rich pictures, to semi-quantitative modeling, and that's where fuzzy cognitive map sits, to more parameterized models that can actually make predictions. And it's not surprising, these qualitative approaches, depending on the nature of the problem you're addressing and the nature of the community you're working with, qualitative approaches tend to be good for identifying the problem. So starting with understanding what different communities are facing to really identify what needs to be addressed. These semi-quantitative approaches give a pretty good idea about structuring the nature of the problem and beginning to collect data about it. And then, of course, the quantitative modeling is really good about analyzing it and making kind of what-if predictions. Now, of course, with stakeholder groups, it's going to be easier to work with qualitative approaches and semi-quantitative more than quantitative. These take longer. So there's resource considerations and all sorts of considerations when looking at these different methods that are available. We also, in this meeting group, came up with, what are the trade-offs of these different approaches? Because obviously it's not that one tool is not going to fit all the problems. So looking at things like spatial representation, do you need time in your prediction? The quantity, you need a quantitative forecast. How transparent is it working with stakeholders? So even in the workshop yesterday with FCM, there was still, after 3 hours, some question about, well, what's happening underneath the hood of the model? What's not super transparent, where other methods are going to be a lot more transparent. I would say this idea, especially in sustainability, of doing co-production research with stakeholders is normative. Like this is from 2018, there was special, very, not a great issue, but an issue from Nature, special issue on co-production. They basically said this is completely normative. We also see it in convergence research at the National Science Foundation, where convergence research is driven by a specific or compelling problem. So this idea about doing work, especially around wicked problems, even if we're talking about public health, but certainly in the environmental field, we have to work with people. We cannot separate those things whatsoever. I think that's just where we are in terms of a normative approach to research now. So then the question is, where do we go next? So I came up with mental modeler, that was useful. I got other people that were smarter than me together to figure out all the tools that are available. Like, what is the next phase in this research? Well, one thing that I'm very interested in is this idea about knowledge diversity. And how can we capture different forms of knowledge and put them together in one shared model? Now, keep in mind, all of us have very different, slightly different at least, even though we all share some cultural aspects, mental models about the nature of, let's say, an environmental problem. But how do you put that together in a parsimonious way that actually improves decision making? And how do you measure whether or not, because you could imagine putting everybody's ideas together and making us dumber. But if there was a project that I was a part of at Rutgers, we were working with 8th grade students trying to teach them agent-based models to understand the nitrogen cycle, and we actually made them stupider. Our model was bad, so it confused them. It took models away, and they took information away when we did the pre and post. That can happen. Everybody tends to think, oh, okay, well, we're always going to be better with these decisions, but we need empirical evidence to show that. At the time, I was in Berlin working at the IGB, which is the Leibniz Institute of Freshwater Ecology. And I was working with a lot of fisheries biologists, and they were doing some fascinating work about collective behavior in fish schools and the role of diversity in understanding how fish schools operate, which I thought was very interesting. They were also doing work on the personality of fish, which is an interesting idea, the personality of fish, like how different fish behave and how risk tolerant they are. But there are some really, really smart people there doing some really interesting work. So I started to think about, well, how can we apply some of this collective ideas that we kind of think exist in the natural world? I'm not going to call them laws, but these general principles, how do they apply to social systems and the way humans interact? So then I got into this idea. This is when I first heard the term collective intelligence, and this is a very subpart figure from Wikipedia that just kind of identified that collective intelligence requires cognition, cooperation, and coordination. But it's a little bit toothless. You know, this is not terribly interesting, so I think we need to drive this forward a little bit, and I'll talk more about that in a bit. So what I started doing is, well, I like this idea about collective intelligence. It's a new way to think about co-production of knowledge. What has been happening in the conservation era so far that gives us evidence that this has been happening? Because I'm calling it a different thing, but certainly things like collaborative problem solving, knowledge co-production has already been around in the environmental literature for quite a bit while. And so I began to think, well, some of these things are socially influenced, where people are getting together, debating ideas, and negotiating through them. Some of them are socially influenced, but also maybe independent. Think about eBird, collecting bird information, sending it to a scientist at Cornell to put it all together. So that is going to be completely independent in some cases. And then there's completely socially independent, which is ideas about wisdom of the crowd, and I'll talk a little bit more about that as we go. But were already examples of different forms of what I would call collective intelligence. The environmental social science or decision-making literature was just calling it something else for a long time. So what are the implications if we can figure out certain principles of collective intelligence? Can we use them to improve environmental decision-making? And how do we know if it works? Again, how do we know if the decision that comes out of it is better? So I'll talk about, 3 studies that are kind of exploratory, trying to apply principles of collective intelligence specifically to, it turns out it's mostly to fisheries, because that's my background and I happen to know it pretty well, but it could be anything else. The first one is comparing swarm intelligence. So that's going to be a socially moderated decision-making process with wisdom of the crowd, which is going to be completely independent. And I'll talk about what that looks like. 2 is moving beyond point estimates. Can we have crowds approximate complex systems? So rather than jelly beans in a jar and coming up with an answer, can we kind of think about it in terms of an ecosystem? And what is the role of knowledge diversity in improving crowd performance in these contexts? So I'll start with this first one. And it was in Berlin when I was at IGB that I first heard this story that you probably already know at this point in time, but I was just fascinated by it. So the wisdom of the crowd was identified by Sir Francis Galton, where he went to an agricultural fair in the UK, and there was a contest to guess the weight of a dead ox. And he collected all 1,000 individual estimates and then took the mean of those, and it was within 1 pound of the actual weight of the dead ox, which is to say, everybody individually got it wrong, for overestimates and underestimate, but the crowd collectively got the right answer. And so I remember doing this in 4th grade with a jar of jelly beans. In my 4th grade class, like whoever got the closest was going to get the jelly bean jar, but the mean of everybody's guesses was accurate, whereas all individuals were way wrong. So I was very fascinated by this. So I was like, well, why don't we, instead of jelly beans, why don't we put fish in that jar and see if fishermen can do the same thing? I mean, in theory, it should work. So I wanted to compare that, that's the wisdom of the crowd approach, to social swarming, this was like 2016, 2017. Social swarming got a lot of press because there was this new software called UNU that I'll talk about, where people get together and make collaborative predictions about stuff. And again, for a context, I wanted a system that I know, so I use striped bass off the coast of Massachusetts, which is primarily a recreational fishery, but it's also a commercial fishery. So it's kind of, and we know a lot about it. It's not a very enigmatic system. The crowd for this was 31 individual anglers who are part of a striped bass fishing club. So we know they're knowledgeable, right? Because this is another point. You could ask my son and his friends to estimate how many striped bass there are, and they're not going to do well. So, who holds knowledge is incredibly important and turns out to become incredibly complex later on. So we had 31 anglers, and we were using this swarm intelligence called UNU. And what people do is people log in synchronously. They're all one of those little horseshoes, and they pull that little puck, what it's called, toward an answer. And they had gotten a lot of press because in 2016, I think, they made a $12 bet on the Kentucky Derby and won the Triple Crown by keep betting it and having individuals say who was going to win. So they turned $12 bet by using UNU into 12,000. And so this, of course, got a lot. Now, the next year, I was going to make a bet based on what UNU said, and the track was muddy, and they did not make the prediction. So they're very interesting. So a new little variable came in and changed the course of everything, which I thought was really interesting. And so if we want to apply this idea with wisdom of the crowd or swarm intelligence to fisheries, there's basically, and this is kind of a joke because fisheries management is hard, but there's basically two things you need to know: how many fish there are and how many fishermen there are. At its base, that is what fisheries management is. And so we asked the crowd individually to estimate the demographics of the striped bass stock. And then we had data from NOAA to compare it to. And what you'll see, this is also another interesting as far as diversity goes. 55% of those anglers were on the shore. So they're monitoring a certain aspect of the environment. And 38% were offshore. So you have observers at different places. Now, what it turns out, if you take the mean of the shore folks and the mean of the offshore folks, you get a better answer at the end of the day, which is very interesting. But this is their recreation of different size limits, which correlate to age for the fish stocks. And it's funny because when I first did this analysis, I was like, oh no, like they missed this one. And then it occurred to me, there's probably a lot of measurement error with NOAA's data, and the reality is probably somewhere in between, I suspect. But everything else was very, very consistent. And we also asked them to estimate the number of anglers in Massachusetts. And we have licenses for that. And again, if you take the shore folks who kind of underestimated it and the boat folks that overestimated it, you get very, very close. And there's really no way in which anglers in Massachusetts should know how many anglers there are in Massachusetts. So it's pretty fascinating. So we have this idea about jelly beans. We can move from jelly beans over to fish, but can we move beyond just those point estimates? Because if you think about the nature of the estimation tasks of how many jelly beans or how many fish, that's one specific point. What about more complex systems? Will it work when crowds are wide? So here we're going to put a freshwater lake ecosystem in the jar and see how well the anglers do. So we wrote a paper about this, wisdom of stakeholder crowds and complex social-ecological systems. And for this is when I was in Germany. We use a very well-known species, the northern pike, which is a very, very popular recreational fisheries in Germany and actually all of the northern hemisphere. And we have 200 individual anglers make mental models of how they understood what influenced the pike population. So how do these little ecosystems work? And then we took all of those different mental models and we put them together to see what certain patterns were, to see basically what does it look like when you take the mean of all these individual responses. Now, for this, we don't have, we have NOAA data to show how many anglers we have. For this, our reference point for how well they do is going to be 17 different fishery scientists that were working on pike. We took all their ideas together to get a reference model to see if the angler model was reasonable to the fishery science model. And what's interesting is in Germany, freshwater fish are privately held resources. from angling clubs that have a legal responsibility to maintain the sustainability of the lake. So they have to manage it for the lake population. And there's one of three positions you can have in those angling clubs. And to be a fisherman, you have to be a part of these angling clubs. You can just be an angler, you're just going to use the water. You can be a club manager, so you're administratively doing stuff, or you can volunteer to be a water manager, so you're actually interacting with the lake. So there's three different types of perspectives of anglers within these clubs. What happens is if you take the within group integration for just anglers, club managers, and just fishery managers, then you take all of those and put them together. You're moderating some diversity, and you get pretty close to approximating, then you get rid of the noise. The angler model that puts everybody together is very, very similar to the fishery science model, but something like 70%. And of course, you compare this to random graphs to make sure that this is just not some weird artifact. What's also interesting is these clubs have different ways in which they can manage these lakes. You can stock them, you can do habitat restoration, spawning grounds, you can limit how many anglers are on them. They have a bunch of tools available to them to make sure that the fisheries are sustainable. What's interesting is if you look at the different types of groups, anglers, club managers, and fishery managers, they all tend to kind of concentrate on something different in the system. So anglers were more concerned about angling pressure and a little bit about riparian. Club managers were thinking more in terms of refuge. And then fishery managers were also thinking in terms of refuge, but less about these other things. And when you take all three of those groups and put them together, you get a very good overlay into how fishery scientists think about this. And what's interesting about this is that is to say, everybody has a little bit of different bias, but when you mediate that diversity of bias, you get something that is at least pretty close to scientific experts. All right, so we got these jolly leaves, we put fish in there. We can put this in there. What about problems where we don't have an answer? Like what about climate change impacts or something like that? Can we do it? The answer is yes. We wrote a paper about this. Again, we're going to go back to the striped bass fishery, but the diversity bonus and pooling local knowledge about complex problems. But how do we know if we take a bunch of people's mental models about an uncertain future that that's actually a good model when we don't have a reference point for it? And there's this assumption, kind of, that group performance is just going to go up linearly as diversity increases. But I would suggest that it is absolutely not. There's going to be a peak type of diversity, and then it's going to start to fall apart. If people can't have the same language to even communicate, for example, like it's not going to be better, even though it is more diverse. So there are limits and costs to diversity in some ways. The thing is to figure out is how do you get to that peak, and how can we engineer this in some ways? We go back to the striped bass fishery in Massachusetts. And what we did this time was we asked them a question about warming ocean temperatures and climate change affecting the striped bass population. And we crowdsourced this. So we paid anglers, all the individuals, $50, and we knew they were knowledgeable about it, to make models and then send them to us using Mental Modeler. And what we did was we put all of those together for a crowd map. So we have each stakeholder group model, meta model, and then we have the crowd models. We have 4 all together. This is just what's interesting about this is what they tended to focus on. So each group was going to focus on a different aspect of that social ecological system, because where they are in that system and what they get out of it's going to be a little bit different. We can look at that a different way and just kind of like look at what they included in the model. And in this particular case, we gave them, I think, 6 concepts, and they could add other concepts. So we wanted to constrain it a little bit so we could put these together, but also we didn't want to over constrain it. We wanted some flexibility. The commercial fishermen tended to think about and represent stuff in the biological aspect of the system. Anglers, recreational fishermen, tended to focus on social aspects, which is also not surprising. Managers focused on management more than anything, that's the pink one. And then when you put them all together, you kind of see an even distribution of each of these factors that just happen to come out. So there's a lot more evenness with the crowd model compared to the others. We can run scenarios on these. And one of the things we did was we blinded the models and did, I don't know, I think it was 8 interviews with fishery scientists in Massachusetts and in DC. And we said, which model's best? And they could look at the structural characteristics of the models, just the angler model, just the commercial model, just the management one, and they could look at the crowd model. And 7 out of the 8 times the crowd model was deemed better. We also compared it to an ecosim model as well, and the crowd model outperformed all the homogeneous models from the other group. So we had a reference point that Noah's been working on for 30 years, just adding information to this model in Massachusetts. So that was the scientific knowledge. So from both expert panel and from scientifically the best scientific information, the crowd model outperformed all the other ones. So we can move all the way to maybe some uncertain problems in some way. So we have some basic principles, design principles that hopefully we can use. But going back to this idea about collective intelligence, this is not necessarily by any means like a how to use this for managers or even for research. So we begin, this is a paper that I've been writing for 6 years, that will never be published, but it did come, it just won't. I love it too much, and so I just end them. But I began to think about like, what are the constituent parts of collective intelligence if we want to use them for different sustainability goals? And there's basically 3 different dimensions that we need to think about how they fit together. The nature of the collective. Are they small collective? Are they large collective? We're talking about 1,400 people. We're talking about 14 people. How diverse is that group? Is it functionally diverse, or is it just diverse in other ways? The nature of the problem itself. Is it creative? Is it a point estimate? Is it trying to predict the future? Is it coordinated action? And the nature of the method. There's a lot of different ways that we had to figure out the best way for the studies we were doing is how to integrate all that stuff together. It turns out if you take the median of the mean of the groups, you moderate a lot of the noise in the models when you're putting those mental models together. That works pretty well. But it took us a while to figure that out compared to random models. We also started thinking about this with Phil Levin and some folks about the nature of different plausible explanations for reality. We wrote this fun paper in, I think it was Bioscience, about the Rashomon effect. And the Rashomon effect is named after this 1950s samurai movie, where there's basically 4 different tellings of how the samurai died, but no one ever tells you which one is true. And they're all plausible. So this idea about plurality of reality, of explaining phenomena where they're all reasonable, none of them were wacky. It's a very interesting idea. So then we started thinking, well, how do we see this expressed in conservation? And we start to look at the literature, and you start to see how people define different aspects of like, what is a species? What is a keystone species? There's a lot of variation in the language and the literature about how we talk about these things. We kind of assume we know what we're talking about. In another study that I did years ago, we did, 45 interviews with different stakeholders around the Baltic cod fishery. And we looked at the transcripts, and everybody said the word fishery, but they meant 6 different things. There were 6 different ways in which you could define a fishery. Of course, that we all think we know what we're talking about when we're talking about this, but they're very, very different things. So what are the implications, though, and maybe some of the negative implications of these different reasonable forms of reality? We did a paper a couple of years ago where I got to, this is a career first, I got to coin a term. It has not gone on very well, it's not been picked up, but I love it. Urbanized knowledge syndrome. And what we did here, or UX, is we collected 1,400 mental models online about how different residents viewed their coastal ecosystem, right? And shoreline protection, given some ecosystem services and so on. And we looked at all this area is pretty much built up, as you know, but there was, we think we use the CDC designation of like this urban to rural gradient. And what we found is we put all those mental models into a clustering analysis. 2 big clusters came out. One set of mental models that understood the coastal systems to be pretty simple, and these mental models happen to be more homogeneous. And another one where the models were more complex and they were more diverse. And what's interesting is we also correlated these with environmental behaviors and whether these residents were living in a more urban area or a more rural area. And the 2 big findings that came out were residents living in more urban areas had simpler and more homogeneous mental models compared to residents in more rural areas. And residents in more rural areas with more complex mental models reported more pro-environmental behaviors. So there is this potential erosion of how we understand when we're living in the built environment, and that's what we're attuning to compared to other places. So anyway, site UX, it's huge. And I was asked to kind of talk a little bit about diversity, equity, inclusion. And it's interesting because I do feel my work is really centered around the functional outcomes of diversity. And it's interesting to separate this as like a moral guiding principle versus something that has real payoffs. Scott Page at the University of Michigan has made a career talking to businesses who are a little bit recalcitrant to promoting diversity and saying, if you do this, you're going to build sprockets better or whatever. The entire institution is going to be better if you put the right effort into putting together diversity in some ways. And what's interesting is when I think about diversity, I think it is the first question you have to know, like how do you measure knowledge diversity within a room? as a functional trait and not as a superficial trait. So there's two different types of diversity that are talked about. One is deep, which is how I problem solve and compare to other people. And the other one is stuff you can see. And I think we need to do both of those things. We need to understand how those things correlate. They tend to, but we don't always know. But I think we should be, I mean, we're researchers, most of us scientists, we should put empirical data and argue this that has real payoffs for everybody. So if you understand diversity, then you can figure out, well, what is equitable among those diverse actors. So I think you have to understand diversity before you understand what is equitable in those spaces. And then to reach equity, you might have to figure out new ways of inclusion, right? What is the saturation point about knowledge diversity? So I would just say, leave you with this: diversity is essential to make all systems more resilient. They can respond to shocks in many ways. They come with different characteristics. So for example, an economically diverse area is going to be more robust than Detroit, where I live near, where there was one industry, and when globalization happened, it completely collapsed. But having more like economic institutions and so on, they're going to be in conflict for the market, but that conflict is good. Same thing for species within an ecosystem. You want two species filling the same niche, competing for the same resources, because if one falls out, you still have that functional role. So we've begun to work with people at the Smithsonian on a conceptual paper, trying to think of what are the relationships between biodiversity, economic diversity, cognitive diversity, and what are the principles of each one of these things. So we've been having a fun conversation in the last 2 months, coming up with general characteristics of what we think exist across these systems that we want to promote to make them more robust to change. And we have, it's interesting because you can use Shannon's index for all sorts of measures of diversity. It doesn't just have to be biodiversity where it came from. We can look at managing biodiversity across, we're looking at coastal areas. Economic diversity does the same thing. And I just need to remember to come figure out how to measure cognitive diversity across huge spatial scales, because I haven't yet, but we do have some idea using mental models, putting together groups of superficially different groups and their mental models to see how we can promote like cognitive diversity in team performance. And with that, I've done a lot of this work with a lot of graduate students over the years, and I'll take any questions.